NASA TRACERS mission, unlocking the secrets of Earth's magnetic shield. In a groundbreaking move, NASA has launched its latest mission, known as TRACERS, which aims to delve into the ways Earth's magnetic shield safeguards our planet from the potentially harmful effects of space weather. The name TRACERS stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites. This mission took flight at 11:13 a.m. Pacific Daylight Time, 2:13 p.m. Eastern Daylight Time, on Wednesday, aboard a SpaceX Falcon 9 rocket, departing from Space Launch Complex 4A at Vandenberg Space Force Base in California. Acting NASA Administrator Sean Duffy expressed pride in this mission, stating, "NASA is proud to launch TRACERS to demonstrate and expand American preeminence in space science research and technology. The TRACERS satellites will move us forward in decoding space weather and further our understanding of the connection between Earth and the Sun. This mission will yield breakthroughs that will advance our pursuit of the Moon, and subsequently, Mars." The TRACERS mission features 2 satellites that will fly in tandem, maintaining a close formation with just a 10-second interval between them as they pass over the same geographical location. Over the course of a year, these satellites are set to take an impressive 3,000 measurements, creating a detailed timeline of how magnetic reconnection evolves. Alongside TRACERS, the Falcon 9 rocket also carried 3 additional small satellites: NASA's Athena EPIC, Economical Payload Integration Cost, PExT, Polylingual Experimental Terminal, and REAL, Relativistic Electron Atmospheric Loss. These satellites are designed to test new technologies and gather valuable scientific data. All 3 missions were successfully deployed, and mission controllers are now working to establish communication with them in the coming hours and days. The ground team for the TRACERS mission successfully established contact with the second satellite at 3:43 p.m. Pacific Daylight Time, 6:43 p.m. Eastern Daylight Time, approximately 3 hours after its separation from the rocket. In the following 4 weeks, TRACERS will undergo a commissioning phase, during which mission controllers will verify the functionality of its instruments and systems. Once this initial phase is complete, the twin satellites will embark on their primary mission, which will last for 12 months. Their focus will be on studying magnetic reconnection, a process that plays a crucial role in understanding how solar activity and space weather impact our daily lives. Joe Westlake, the Heliophysics Division Director at NASA headquarters in Washington, emphasized the importance of this mission, stating, "NASA's heliophysics fleet helps to safeguard humanity's home in space and understand the influence of our closest star, the Sun. By adding TRACERS to that fleet, we will gain a better understanding of those impacts right here at Earth." The TRACERS satellites will orbit through a unique area in Earth's magnetic field known as the polar cusp, located near the North Pole. This region is particularly interesting because it is where explosive magnetic events occur. These events happen when the Sun's magnetic field, carried by a stream of solar material known as the solar wind, collides with Earth's magnetic field. This collision generates a significant buildup of energy, leading to magnetic reconnection, where magnetic field lines snap and realign explosively, ejecting nearby particles at high velocities. By flying through the polar cusp, the TRACERS satellites will be able to study the aftermath of these magnetic explosions. They will measure charged particles that descend into Earth's atmosphere and interact with atmospheric gases, providing scientists with the necessary data to reconstruct how variations in the solar wind influence the transfer of energy and particles into near-Earth space. David Miles, the principal investigator for TRACERS at the University of Iowa, remarked, "The successful launch of TRACERS is a tribute to many years of work by an excellent team. TRACERS is set to transform our understanding of Earth's magnetosphere. We are excited to explore the dynamic processes driving space weather." In addition to TRACERS, the mission includes several small satellites. The Athena EPIC mission serves as a pathfinder, showcasing NASA's innovative and adaptable commercial smallsat architecture. This approach aims to enhance the flexibility of payload designs, streamline launch schedules, and reduce overall mission costs, while also highlighting the advantages of collaboration with federal partners. After completing its 2-week commissioning phase, Athena EPIC will spend the next year measuring outgoing long-wave radiation from Earth. The PExT demonstration is particularly noteworthy as it will test interoperability between commercial and government communication networks for the first time. It will utilize a wideband polylingual terminal in low Earth orbit, which can switch between different networks using software-defined radios, much like how cell phones roam between providers on Earth. This capability could enable future missions to seamlessly transition between networks and access new commercial services throughout their operational lifespan in space. The real mission, a CubeSat, will investigate how energetic electrons escape from the Van Allen radiation belts and enter Earth's atmosphere. These belts, which are shaped like concentric rings above Earth's equator, contain a mix of high-energy electrons and protons that are held in place by Earth's magnetic field. By studying these electrons and their interactions, the real mission aims to enhance our understanding of these energetic particles, which can pose risks to spacecraft and astronauts traversing through them. The TRACES mission is spearheaded by David Miles at the University of Iowa, with support from the Southwest Research Institute in San Antonio, Texas. NASA's Heliophysics Explorers Program Office, located at the Goddard Space Flight Center in Greenbelt, Maryland, oversees the mission on behalf of the Heliophysics Division at NASA headquarters in Washington. Various institutions, including the University of Iowa, Southwest Research Institute, University of California, Los Angeles, and the University of California, Berkeley, are responsible for leading the instruments on TRACES. The Athena EPIC mission is directed by NASA's Langley Research Center in Hampton, Virginia, in partnership with the National Oceanic and Atmospheric Administration, U.S. Space Force, and NOVAWORKS. The launch of Athena EPIC is supported by the launch integrator SEOPS. The PExT demonstration is managed by NASA's SCAN, Space Communications and Navigation, program in collaboration with the Johns Hopkins Applied Physics Laboratory, with launch support from York Space Systems. The real project is led by Dartmouth College in Hanover, New Hampshire, in partnership with the Johns Hopkins Applied Physics Laboratory, Montana State University, and Boston University. This project is sponsored by NASA's Heliophysics Division and the CubeSat Launch Initiative, and it was included through the launch integrator Maverick Space Systems. NASA's Launch Services Program, based at the Kennedy Space Center in Florida, is responsible for managing the VADR, Venture Class Acquisition of Dedicated and Rideshare, contract. For more information about the TRACES mission, you can visit https://nasa.gov/traces. And Abby Interonti/Karen Fox. Headquarters, Washington. 30120101224/2023581600. abby.a.interonti@nasa.gov/karen.c.fox@nasa.gov. Sarah Fraser. Goddard Space Flight Center, Greenbelt, Maryland. 20285379191. sarah.fraser@nasa.gov. SpaceX launches NASA's TRACES mission to protect Earth from solar storms. In a groundbreaking event, NASA's TRACES mission successfully launched from Vandenberg Space Force Base in California on July 23, following a 24-hour delay due to airspace concerns. TRACES, short for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites, is a mission comprising 2 satellites designed to investigate how solar wind surges trigger magnetic reconnection in Earth's magnetosphere. This process funnels charged particles towards the polar magnetic cusps, resulting in spectacular auroras and potentially disruptive geomagnetic storms. By positioning 2 satellites in close proximity, TRACES aims to capture rapid changes in Earth's magnetic field during reconnection events. These events occur when the solar wind, a continuous stream of charged particles from the Sun, interacts with denser patches from coronal mass ejections. Meanwhile, Earth's magnetic field fluctuates throughout this interaction. The satellites were launched aboard a SpaceX Falcon 9 rocket at 2:13 p.m. Eastern Daylight Time, 18:13 GMT, 11:13 a.m. local California time. Initially scheduled for July 22, the launch was postponed due to airspace issues. The Falcon 9's first stage made a successful landing at Vandenberg approximately 8 minutes post-launch, marking its 16th mission. The upper stage continued its journey, placing the Tracers duo into a low Earth orbit at an altitude of 367 miles, 590 kilometers. Accompanying Tracers on the Falcon 9 were 2 private spacecraft, Light and Skycraft 4, along with 3 additional NASA missions. One of these, the Athena EPIC smallsat, will test a new method for efficiently deploying Earth-observing instruments into orbit. Another, the Polylingual Experimental Terminal, aims to demonstrate improved satellite connectivity by enabling spacecraft to switch between communication networks in space. Lastly, the Relativistic Electron Atmospheric Loss, REAL, mission, a CubeSat, will explore how high-energy particles in Earth's Van Allen radiation belts are scattered into the atmosphere, with potential applications for protecting satellites from harmful particles. All payloads, including Tracers and the accompanying satellites, were scheduled for deployment within a 50-minute window starting 55 minutes after launch. This mission not only advances our understanding of space weather but also paves the way for innovative technologies to protect our satellites and infrastructure from solar storms. Stay tuned as we continue to explore the mysteries of our universe and the impacts of space weather on Earth. University of Iowa Tracers Satellites Launch, Unveiling Space Weather Secrets. Imagine the culmination of years of dedication and hard work, all encapsulated in a moment of triumph as twin satellites, meticulously crafted by University of Iowa researchers, soar into the vast expanse of outer space. This monumental achievement marks the successful launch of the Tracers project, an acronym for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites. The University of Iowa celebrated this historic event with a watch party, inviting contributors and the public to witness the SpaceX launch that propelled these satellites into orbit. The Tracers project stands as one of the largest research endeavors in the university's history, involving dozens of students, professors, and researchers. Some students were directly involved in the construction of the satellites, while others, like Brandon Powers, will delve into the data collected by these celestial explorers. Powers expressed his excitement, stating, "It's super exciting. It was a great launch, it was perfect. We'll know within a few weeks how the instruments are doing and when we'll actually start collecting data and doing science with it." The primary mission of the Tracers satellites is to help scientists understand the intricacies of space weather, including the impact of solar wind. These winds can sometimes reach Earth's atmosphere, causing disruptions to other satellites that provide GPS and various signals. Powers elaborated, "We have a team that can inspect that data, basically determine what weather events are the most interesting and what events are less interesting." But here's where it gets controversial. The launch was a bittersweet moment for many, as they remembered Craig Kletzing, the visionary behind the project. Kletzing passed away before the Tracers could be launched, but a piece of him was symbolically sent into space. Allison Janes, University of Iowa Associate Professor for the Department of Physics and Astronomy, shared, "The decision to put 2 of his guitar picks, one on each spacecraft and send it into space was an amazing idea, and they went through so many bureaucratic hoops to make sure those picks could be on the spacecraft." The satellites are expected to remain in orbit for at least a year, but if the mission is successful, they could stay in space for an extended period. Janes explained, "We're hoping, and we often see with these missions, that we get extended missions, and those extensions can go out for years depending on the health of the spacecraft and the instruments. So 1 year for sure, and we're hoping for more. And this is the part most people miss. The Tracers project not only represents a significant scientific achievement but also serves as a poignant reminder of the human element behind such endeavors. The inclusion of Klatsing's guitar picks adds a personal touch, making the mission even more meaningful. As we celebrate this triumph, it's essential to ponder the balance between scientific progress and the emotional significance of such projects. Do you think including personal mementos in scientific missions adds value, or should such endeavors remain purely objective? Share your thoughts in the comments below.